Hello, this is Dr. Kevin Connors, and we're starting a series on apoptosis. So if you don't know what that word means, you're going to learn all sorts of things about it. This is going to start slow but get kind of advanced through this series. So it's kind of like we're going to call it a college level course. Apoptosis 101 is where we're going to start. A little bit more simplistic, but when we get to 601, stay with me, if you will, please, because that's when we really get into some things that you can do from a natural perspective to stimulate this thing called apoptosis. That's what you want to do if you're dealing with a diagnosis of cancer. So stay with me. There'll be a lot to go through with this. So Apoptosis 101, the definition of apoptosis is normal programmed cell death. Normal programmed cell death. This is a normal process that we want our cells to go through. There's only a very specific amount or type of cells that don't go through apoptosis in our body. Most cells go through apoptosis. That means they have a life cycle, they have a lifespan, and they live that lifespan, and then our body gets rid of them through a normal physiological process. It's been called cell suicide because that's what really takes place inside the cell. There's two different processes, an intrinsic and extrinsic process that we'll explain ad nauseum in our more advanced little levels here. But it is really a normal process that our cells go through to create a new cell. Your body is a new body over time. Yes, it might be degenerating because as we age, we reproduce a less than healthy cell than it was previous. And so that's part of the aging process. But if we didn't go through apoptosis, we'd end up all with cancer. So we'll discuss this as we go here. So there's two real ways that cells die in our body. One is apoptosis that we're going to go over. The other is necrosis. So necrosis is different than apoptosis, and we're going to explain that. Apoptosis is what I said, a purposeful stimulation. It's induced by the cell or the cell membrane, and it's purposeful to get rid of that cell because that cell already produced a baby cell, and now this mother cell, it's time for it to die. It requires energy. It's gobbled up by macrophages, which are part of your white blood cell, your Th1 system, in a process called phagocytosis. So there's no waste. It's all very conserved. It's very detailed. It's a detailed process. So as I said, it's normal. It can be pathological, meaning we'll discuss that. Like chemotherapy and radiation produces a pathological apoptosis. But if we didn't have that, if there was no radiation poisoning or something like that, then we'd just be talking about the normal physiological apoptosis. On the other hand, necrosis is toxicity induced. It's passive. The cell isn't purposefully killing itself. It releases waste. The cell is being murdered. So one way to look at it, apoptosis is normal death of the cell. Necrosis is someone from the outside murdering the cell. The cell didn't want to die, had no purpose in dying, but it was killed by an outside factor. It is always pathological, necrosis is. So it's important to understand the difference in this. It has a different effect on our body too. When our cells go through apoptosis, they start to shrink. We'll explain that. And they're basically imploding upon themselves. They break off into little teeny bodies, and those little teeny bodies are gobbled up by these hungry macrophages that gobble it up and eat it up. The components of that cell then are conserved, it's recycled. So apoptosis is a natural recycling of our cell genetic material. So nothing goes to waste in apoptosis. It's not inflammatory. So normal programmed cell death doesn't cause a huge amount of inflammation, doesn't cause any degeneration. There's no bad things happening in apoptosis. It's a normal event. And it happens one by one. Versus necrosis, it can involve many. So necrosis, because of, let's say, a bacterial infection that's eroding away your skin, many cells are dying. It's giving off tons of waste, tons of inflammation. You're losing cell components. There's absolutely no recycling going on. It's just waste, waste, waste. The cells are exploding. They're rupturing. Cell components are going all over. There's no recycling taking place. That is a terroristic attack on a cell structure. Necrosis is. Versus apoptosis is someone living to 95 years old and dying, and the wonderful funeral explains the wonderful life of this individual, and everybody's happy that they moved on now to heaven. That's apoptosis. So the program of apoptosis that we'll get into here in our later little lectures causes the cell to start shrinking. So you see my little arrow there on the apoptosis side. If you look at this picture, this has a normal cell. On the left is necrosis taking place, and you look at the end of necrosis is cell material being spewed out, no recycling taking place. The cell was murdered. On the right-hand side, you see apoptosis. It starts to shrink. Things are being destroyed from the inside out, and we'll explain that in detail. And eventually, these little shapes take place on the outside of the cell membrane and starts to break off. These are called blebs. Their indented membrane surfaces start to indent upon itself. And then specific lipid molecules stick to that cell surface, and they're attractants. They're like little sensey things. So macrophages, white blood cells, go, ooh, there's something looks really good over there. I can smell it. That is a dying cell. And macrophages, which are white blood cells, sniff out these dying cells, and they go, oh, these look really tasty. And they gobble up these little blebs, and they recycle that material, and everything goes exactly the way it was supposed to. So our next piece, we're going to get into why this is important, because it is so, so important. I love to garden, and if you don't prune your carrot patch, you are never going to get a good crop of carrots. If you don't prune your tomatoes, if you don't prune your apple tree, you're never going to get a good crop of apples. You have to do this. This is part of life. It's just what takes place in a healthy environment is this shaping or pruning. We see pruning take place in an embryological, neurological system, and we're going to get into this pruning and why this is important in our next session with this. I'm trying to keep these short so they're just not too much information. But let's sum this up. Apoptosis is very controlled. Your body is controlling this. Your body is desiring apoptosis. So it's a program pathway. It's very specific and very detailed. And this is why we're going to see why different things like viruses and bacteria and toxins and poisons can affect this intracellularly, meaning inside the cell. It can break the pathway so that apoptosis doesn't take place. And of course, we know if you've listened to any of my other lectures, that's what cancer is. So what is cancer? A cell that doesn't go through apoptosis when it was supposed to, and a cell that instead of it reproducing every 6 weeks or 12 weeks or 18 weeks, now it's producing 6 or 12 or 18 times a day. It's reproducing itself. So there's a broken pathway. There's a broken apoptotic pathway. It's not dying, in a broken replication pathway. So we're going to get into the details of what chemical pathways these are, as simplistic as I can make them for everybody, but it is important to know that that's what cancer is. Cell not going through apoptosis and a cell stuck in a rapid replication cycle. That's the definition of cancer. So these pathways can be broken. Apoptosis is purposeful. It has a purpose. It cleans up the body. It's pruning cells that don't need to be there anymore, that have lived their lifespan. It is normal. It is typically not pathological, the way we're going to discuss it. In Apoptosis 601, we're going to talk about the pathological type of apoptosis with chemotherapy and radiation. And it's very different from necrosis. Apoptosis is normal lifespan of a cell dying off and having a wonderful funeral. Necrosis is being attacked by a terrorist group and it's killing multiple cells, spewing a huge ugly mess all over. Apoptosis is so necessary to prevent cancer. That's why we're going to talk about this. So how can we stimulate a normal healthy apoptosis in cells that aren't going through that? So stay tuned for next episode, our next class on Apoptosis 201. So watch for that. I hope this helps, and I hope you're being blessed.